Thanks for downloading this episode of the BimTube Podcast. Just a reminder that you can access all the podcasts in video and audio if you visit bim.tube. So our website again is at bim.tube. We hope you enjoy this episode. Hello everyone, welcome to this episode of the BimTube Podcast. So today I've got Sam Roberts, so thank you Sam for joining me. Welcome.
No problem, happy to be here.
Great, thank you. And as with a few of our guests in the past, because we're very busy, we've had to postpone this a couple of times, but we are here today because we're busy people. So I do appreciate your time, spending your time with me. So thank you for that. So we both have a geospatial background, so we're probably going to explore that a bit more today. But just for the people that don't know you, if you would kindly just introduce yourself and your current role, but critically, as you may or may not have seen in some of the previous podcasts, what I think is as important is your journey to where you are, how you got to where you are now. So your sort of background, if you would. So over to you, Sam, please.
Right, okay. So start off with my background, really. I trained as started off studying geology, transitioned to archaeology. So my early career was based around sort of academia and then looking at how archaeological materials and things, once they're buried, how they transform in the soil and change. I moved then into sort of archaeological site excavation, working around the UK, and then quickly picked up on to doing geophysical survey. Just found I had a talent and a knack for it. As that went on, my sort of interest expanded beyond just the archaeological realm into all sorts of underground mapping, which eventually pulled me into utilities and the survey profession. And then that's when I joined Met Geoenvironmental, which is the company I'm with now. And for the past 16 years, I've been working on underground survey, underground mapping, utilities, also other types of buried hazards and ground obstructions. As part of that, I came sort of aware of a need for more standards within the field of both utility mapping and underground survey. Got involved with various professional institutions such as the Chartered Institute for Civil Engineering Surveyors and the Survey Association, and then helped develop PAS 128, the survey specification for utility mapping. And we've sort of been pushing that over the last sort of 10 years since it was launched in 2014. I now sit as technical chair for the Survey Association on their committee, producing guidance and standards, and also on the underground and subsurface utilities mapping panel for ICES.
So thanks, Sam. So you're busy. You're on lots of panels. So it's an interesting journey, isn't it, from archaeological to, I mean, of course, it's still underground by definition, but it's working with engineering and AEC and asset management professionals must be a different conversation. Let's put it that way. One of the things I know we thought we might touch on is about the accuracy of underground information. So although that's been a key part of your whole career and your profession, it's maybe we just touch on, for the benefit of people that aren't familiar with what kind of things you might be talking about underground. It might be self-evident to us and other people, but what the assets are, like literally what they are, and then maybe touch on some of the aspects around safety and future productivity. So sorry, it's an extended embedded question, but and then move on to maybe how things are progressing, like to digital twins. So just what's under the ground, and then how are things developing, I guess, to summarize.
Okay, so what are the types of things under the ground? Then there's the obvious stuff like your pipes, your cables, your water supply, your electricity supply, telecoms. Some more so other stuff that might be under there. There's larger tunnels, sort of deeper sewers. There may be things which are not necessarily that well known about, sort of communications infrastructure, or a larger, certainly in London, there's a lot of sort of ducts and deeper stuff to do with possibly the sort of the tube network and lots of other things which are buried. Every time anybody goes out to dig, then they run the risk of obviously hitting some of this buried infrastructure. And whilst there are records out there, some of those records, especially for the older Victorian sewer network, might be like over 100 years old, have been transposed from sort of paper records to other paper records down to digitized onto plans, but the actual accuracy of that information is quite often uncertain and cannot be known until you go out there and try and sort of either resurvey it using geophysical methods, which are the types of things we use, or until you go out and dig and actually find it by visual means. Now, that's probably the worst way of finding something, because it tends to be unexpected. And if that happens and you find something in the place that you don't expect it, it can cause obviously lots of extra cost onto your project, or lots of delays in terms of having to work your way around it, or deal with the problem that it's currently facing. And, you know, for normal people, as opposed to people involved in digging up the ground, then lots of holes in the road and basically delays and traffic chaos is not generally a good thing. So the more information that we know about the underground before we actually get to that stage of digging and excavation, generally the better. That sort of runs on to the idea, I should say, the digital twin. So there are various schemes in place to try and have digital representations of the underworld that people can then access and look at whilst they're either planning the construction of buildings, planning the construction of additional infrastructure, or even just sort of going out and relaying a trench or fixing somebody's electrical supply or their internet connection. That's sort of the main sort of aspect of that at the moment is called the National Underground Asset Register, which is a scheme and a platform promoted by the Geospatial Commission and various of the large bodies in the UK that are involved with geospatial information. And that's looking to have within sort of a few years' time, basically every major asset company's map of their underground assets in a form that can be readily accessed online and can be sort of searched before you go out to site to make sure that you have the sort of the most up-to-date information at any one time. Now, that leads to the next sort of challenge, which is just because something is digital doesn't mean it's right. And so even though we're digitizing all of this information all the time, we're making it more accessible, which is fantastic, because ease of use of information is sometimes as important as the precise sort of accuracy of the information. But then once everybody has all of that information, you cannot forget that just because it's like available digitally, it still may be uncertain. There are sort of limitations on that data, and you need to be aware of those and constantly working to try and improve the data set. Because ultimately, if you put poor data in, then you get a bad result out. And it's very easy. People like to believe what they see on the screen or like to believe what they see on the plan as being the sort of the gospel truth. But it needs to have all of those caveats inbuilt into it, and the knowledge that it's not necessarily correct, because it might just be the same as that scrappy bit of paper that somebody found in a desk drawer like 50 years ago that had been drawn another 50 years before that. So that's what we want to try and keep pushing the boundaries of survey companies to produce better data that can then feed back into these sort of digital platforms and improve the quality of the data.
Great. Thanks, Sam, for that, and apologies for my extended embedded question that made you have to respond to it in one go. I guess if we can, without going at this point into the detail of PAS 128, because I think we'll probably do that later, give it its due. But just, we mentioned quality or data quality and accuracy. For the people that maybe aren't from this sector or new to this, how do we define quality, and what do you mean by accuracy? Again, you're a survey professional. Lots of people aren't, and that they are starting to handle this kind of data. So what do you mean by quality and accuracy?
Okay, so accuracy we'd look at in terms of just how how right is that information? You'd say, in terms of like, so if you have a plan showing an electric cable running on down the left-hand side of the road. Now, if it's on the left-hand side of the road, you could say that's fairly accurate. But you may be on the other side of the road. Then is that it's still in the same road? Is that accurate or not accurate? It depends upon the level of accuracy that you require. Now, just knowing where something is fine, but when you come out to actually do detailed sort of excavations or are designing infrastructure, then you might need to know where that thing is to the millimeter or the centimeter or the meter. So then it's being able to say, well, okay, we know where this pipe is, but we only know where it is to within a meter accuracy or 2 meters accuracy. So it's being able to define that level of accuracy. That's the key thing. And different types of survey techniques can do that to sort of different levels.
And thanks, Sam. The one thing I probably should have started, again, although we both have some geospatial background, or so naturally we're going to talk about this for people that are more simply from a wider information management background. We mentioned geophysics. Now, this might be a silly question to ask you, but what is geophysics? What do you do? Sorry, I know we've gone into the detail already, but just taking it back a minute.
Taking it back. Yeah, to the wide scale.
This is specialized, right? So what is it? Yeah.
So the geophysics is literally the application of physics to the study of the Earth. Now, this can be as simple as you knocking on a wall to try and find a hollow, because you're using the sound quality and the resonance that you get back from a hollow behind a wall to what it is if it's solid brick. And basically everybody's done that. So everybody's used some form of geophysics in their life. But then it's also as complicated as using very sensitive machines which measure gravity across a large area of the site to try and find buried mine workings 30 meters below the ground or something like that. So it's basically the ingenuity of mankind to use common physical laws to try and find out more about the Earth and what is both within it and above it. Geophysics can also be applied to stellar observations and things like that. So it's all to do with, sort of like, using physical laws to try and find out a little bit more about things that we don't know much about.
Yeah, and I thought I'd just ask, because I realised Time Team hasn't been on for a long time, so that they'll actually, and I'm not joking, these things give awareness to people, don't they? Do you know what I mean?
They do.
Exposure, I don't think that's on at the moment, so there'll be a new generation of people that, if they're not from that background, probably not familiar with the terms. So
Time Team did so much to raise awareness of geophysics, geophys, as they used to call it, and also the types of things that it could do, and also a little bit the types of things it couldn't do. Like sometimes they were unsuccessful, and that is part of the whole aspect. There's some things that can't be found due to ground conditions or to the depth of burial, or just to the fact that there's too much other stuff in the way, and that is a constant problem within everything that we do. As an aside, there's a shout out to a friend of mine, Jimmy Adcock, who is a geophysicist who works in the GPR and sort of slightly ground investigation area for Marla. They are doing a new series of Time Team at the moment, but I think it's only available online, and it's streamed via YouTube or different platforms like that. But if there's anybody out there who is really missing Time Team, then it is there to be found if you go and have a look.
Great, thank you. And I can't let you off the hook now, because you said GPR. So can you explain ground penetrating radar in simple terms, please?
A simple term, right? So,
or however you like. It's up to you.
I'll go for it. So ground penetrating radar, it measures differences in materials. Really, generally it should be ground coupled for the best results, although there are some systems that can be raised slightly above the ground. but it fires a pulse of electromagnetic energy into the ground frequency, and then where that sort of electromagnetic wave encounters a material with different properties, it will reflect something back, part of that wave back. And you fire this pulse down, you measure the responses back, and then you can get an indication of what is under the ground and the changes in material and contrasts. It can be used to pick up sort of changes in ground composition, such as different layers of soils, or it can be used to find specific things like pipes, large obstructions, voids, different things like that. It basically works on contrasts. So the bigger a contrast a material has from the surrounding burial material, the larger a reflection and the easier it'll be to find.
Great, thank you. That was okay. That made perfect sense to me. So thank you. I'm sure people get it, and of course radar. Generally, I hope people probably understand what that is, but you never know. What are the other things? So thank you. So I mean, we've got the equipment, we've got the skills. People like yourself, we've got sort of high tech industry linked with, particularly with geophysics. It's one of the things maybe to ask you is. And we did touch on this on the first question, but maybe if you've got anything to add about the current status of utility information held by assets. I know we've already mentioned Geospatial Commission, but how much is wrong? Maybe there isn't a percentage, but in your professional opinion,
Well, I think that goes back to that sort of level of accuracy a bit again. It's like how wrong is wrong, and if you're showing utility run along a pavement and it's within that pavement, that might be right enough. But if you want to put in a new lamppost on that pavement, then you pretty much need to know exactly where that utility is, so you can be sure to miss it when you dig that new hole to put a lamppost in. So yeah, it's a difficult one to quantify in terms of how much is wrong. There is a lot out there that is uncertain information, shall we say. Some of it is plainly wrong. Like you can go out there and you can tell it's in the wrong place on the plan. It's shown absolutely, and that can be problematic for lots of surveys, lots of development projects. Some of it is just merely inaccurate because it might have been picked up at a time when it was being recorded using a sketch plan. So they measured it off a wall or off some other type of feature 40, 50 years ago, which now isn't there. So it doesn't have a fixed sort of reference point anymore. And although you may think the wall that is shown on the plan that you have is the same wall as the one that you see on the site, it might not be. So then it's just lost its actual fixed position in place. So it's difficult to quantify. A lot of assets now are getting recorded as they're installed using GPS and standards such as PAS 256, which is that's a publicly available specification that details with how buried utilities should be recorded. It hasn't had take up from everybody within the profession, but there are some people that use it, and the whole practice of recording stuff more accurately when it goes in is getting more and more widespread, which is only a good thing. But there's still, the UK especially has a long history of putting stuff into the ground, and a lot of that was not properly recorded, or the actual reference points that it used have been lost. So there's a lot to go. I hope that everything from now on gets recorded precisely as soon as it gets put in the ground, so we know where it is for eternity. That'll still give all utility surveyors working in the UK a long career looking for all the other stuff that hasn't been recorded.
Yeah, and I think it's that mixture of unknowns, or mixture of quality, or whatever. You could use lots of words, couldn't we? But yeah, it's a mixture of sources, of methodologies, some of which are literally scientific by definition if it's geophysics, and like you've mentioned, some people sketching. And I like to think, I know you've just said this, I'm just paraphrasing, but maybe you've got something to add, maybe a case study. Obviously you don't need to name any clients or something, but of where things haven't been fit for purpose, because it's always about, well, is it fit for purpose? And your example of something being on one side of the road or not unbelievably may be fit for purpose for a utility, maybe for a utility company. But have you got any? Sorry to put you on the spot. We didn't rehearse this, but have you got any examples? Maybe not yours, but maybe just case studies generally.
No. So I have got an example actually. It's like I've been on fairly recently. The record plan showed a surface water culvert crossing the site from it was about 100 meters long, the site, a road on either side of it, and it showed a culvert crossing the site in a straight line from a manhole in the road above the site to a manhole in the road below the site. We lifted both manholes and the culvert was there. We connected, and the site has got quite a lot of, had a long history, as we say, so it's got a lot of deposits on top of it, so it's sort of mounded and basically not a very easy site to work on. But the culvert, we proved the connection between the two manholes. It's stone built culvert. It all looked all fine. But when we actually came to do some investigation on the site itself, we actually found that rather than a straight line, the culvert curved quite significantly and sort of deviated. I was about 30 meters away from the position where the culvert was shown. Now, that doesn't really matter if you're just worried about the culvert draining water, because it was doing that. But in this instance, the development site needed to put an easement of about 3 meters wide corridor over the culvert, and that would entirely dictate where they were going to put buildings and what they were going to construct and how they were going to plan their site development. Now, if they'd have worked on the basis of that straight line, they would have done all of their designs, and when it came to actually digging up the site and going ahead, they would have found that they had to change everything, and all of that time and money would be wasted on the pre-site development. They'd have to go back, do it all again. That would have delays and knock-on effects on their construction program, leading to more costs. So it's having that accurate information early on in the project cycle is really important.
Thanks, Sam. That is a good example, because it's, like I say, it's, or like you were saying, rather, it's the impact, isn't it? It's the consequence of it. And again, it depends what people do for their day job. It might be the case, just broader than maybe utilities or including utilities, the benefit or the impact might be downstream, as it were. No sort of pun intended, talking about culverts and stuff. But and that's the challenge, isn't it? Who's it going to affect? Because in your example of it being rerouted or at least different, who knows when that happened, or it's like you'll never know. And it's really interesting. Have you got anything maybe to add just about how we actually change that? So how might we introduce a process, procedures, mechanisms, standards, a governance framework to improve?
Precisely. That's what's needed. Ideally, there would be some way of feeding that information back to the relative asset owners, or whether that be public utilities or even just private owners on sites. And so that they can then keep their records updated and have it in a live model, like a digital twin. So you have that stage, whether that be on a nationwide basis or just on a site basis, so that then that information stays current. It has the metadata associated with it as to when the survey was carried out, who did the survey, how the location was ascertained, and the confidence that people have in that location. And then, rather than, we often find now, we go back to sites sort of year after year, often doing a very similar kind of survey to find out the same type of information, because those records have been lost or aren't then trusted in some fashion because they've been passed on from another company, and the new client or new owner doesn't have the confidence in them. And we can say, well, we've done the survey before we found this information, but it's like, well, we want to have ownership of that information. So whereas if you had some sort of model, maybe a GIS system, geographic information system, which contains all of that there, that you could upload that information to when you do the survey, that then becomes a sort of a digital twin, an instance of the truth. And rather than having to redo the whole survey every time, you could just amend it as and when things change on the site. You keep it regularly updated. It's a live model. In the same way as you have building information BIM for building information management, or better information management for above ground structures and buildings and life cycles of things that will increase the cost. Why not extend that to the underground as well? Build the underground into that information model and keep it updated, and then you don't have to keep on wasting money almost, or spending money to find out the new information. You only have to pay to update it and amend it as you go.
Yeah, thank you. That sort of, well, I was going to say vision, it's a reality, isn't it, of a single source of truth or master data. And of course, as we've already mentioned a few times now, digital twins is the, one manifestation of it. But yes, as you've just articulated, GIS really sounds similar. Not all of it. One observation I've got, and I don't know if you've got anything to comment. I guess this is the whole thrust of what we're saying today. One of the challenges traditionally with GIS is it didn't naturally have this feedback loop.
Yeah.
It's a tool, it's a system, it's a platform. It can do whatever you want. The challenge is it was often linear, like one way. You use survey, maybe a map comes out, you use CAD and maybe analysis comes out. And I think this feedback loop is important, isn't it?
Yes, it is. And I think that's maybe once upon a time that was true, that it was linear and people fed information in and then they got one thing out. Now, with the advent of mobile communications and sort of the ubiquity of data connections that allow rapid sharing of data back and forth. So you have things like GIS collector apps where people can go out, collect that survey information in the field. It feeds directly into the main GIS system, and then it can be updated sort of in almost real time, although you probably want some steps in the process to monitor and validate that data. In the same sense, people can go out with those collector apps and see the GIS system there on their tablet, and they can access it and they can check what's needed. Communications can go almost in real time. You kind of do have that mechanism there already. And that's what I've often thought about digital twins. You often see very whizzy sort of models with like large LiDAR stuff and whatever, but a digital twin doesn't have to be complicated. It can be fairly simple, and the simpler it is, the more accessible, the better in a way, because then it will be updated more often. It will be maintained. Everybody will be able to access it and understand it, and then it will be used. And there's no point having an amazing 3D model that's stuck on somebody's PC that can't be used by anybody else because they need, 5 teraflops of data capacity. It's like you need something that is going to be used every day.
Yeah, it's a good point, isn't it, that there's possibly too much information, or it could be too complex. I often make that point when I'm teaching, where it's a bit like the Goldilocks zone, or some other analogy is what I mean, about just enough information. But that's the hard part, isn't it? That's why we'll always need professionals, even though technology, for example, drones, I know we're not talking about that today, or UAVs or UASs, whatever people want to call them. Some things are becoming automated, but not the skill to interpret the data and to say what should be needed in the first place, right? How much data do we need? Not too much, not too little. Have you got anything to say about the risk of sort of again, we haven't rehearsed this, but of sort of non-professional people. So what I mean is people performing survey that are not surveyors. I know you gave the example of the app, but how do we keep that in check, that we're still getting value?
Yeah, so it's the right type of an amount of information for the right project and application, isn't it? So some people need one level of information. If you're, say, a designer of a building, and then you need a different level of information, you need to have confidence in it. How do we keep up those standards? That's where I think things like accreditation schemes come in. We have them throughout the construction and the geospatial, in fact, throughout all of business. there are accreditation schemes which say these people have been checked and monitored to see that they can deliver what they say they're going to deliver. And now in the utility profession, we have a similar thing with PUMA, which is PAS 128 utility mapping accreditation. And that's a new scheme recently launched by the Survey Association, who are the trade association for land surveyors in the UK. And what this scheme aims to do is to go out and meet survey companies who say that they can carry out a utility survey to the PAS 128 level, which is a very rigorous specification. It requires a high level of detail and a high level of competence to be able to carry that out. And so this scheme will send out the assessors to examine the company, see that they've got the management structures in place, see that they've got the training structures in place, see that they make sure that they utilizing qualified staff, that they then have the site procedures in place that will work to this specification and deliver the information that's needed. And they also have the follow-up kind of sort of like data support and data management procedures in place to ensure that all of that data gets processed correctly, gets delivered to the client in the correct formats. And you have then people who need to have a PAS 128 survey done can have the confidence that if they go for a PUMA accredited company, then they will be getting what they've asked for.
Great, thank you. And just for clarity, that obviously is for survey companies who are performing it, or is it for others that could get it?
Well, just as PAS 128 is a publicly available specification, the actual PUMA accreditation, if you're a company who say that you can do the PAS 128 survey, you can apply for the accreditation. Now, as part of that, currently it's only open to the Survey Association members, because the Survey Association carries out its own checks on any members who join the company. It checks their validity and standing as a business. It's not just sort of open to fly by night people who've just set up. They need to have been set up for a certain period of time, need to be successfully trading, need to have certain structures and procedures in place that you'd expect from any reputable company. And then the PAS 128 accreditation is like an extra level, which is aimed at companies who make a business in undertaking utility surveys.
Great, thank you. And I love standards. I love raising awareness. That's the whole point of the podcast, right? It's generally and a lot of the things we've talked about information governance and standards. There are standards, and of course one of the ones that I like is ISO 19650, the BIM standards, but let's not talk about that today. Let's talk about the PAS 128. I think one of the challenges I find is awareness and client awareness. Have you got anything to say about that, about our clients, and generally, maybe outside of PAS 128 as well, just generally, are clients as mature as they should be, and what can we do about it if they're not?
I think we're getting there is the answer. It's you never reach the destination. Probably there's always more to do, because people are always joining an industry, they're always learning more and moving on through it. Since PAS 128, the specification was launched back in 2014, and now there's been a groundswell really of people using it. Pretty much all of the main larger construction companies that we get requests from, a lot of the smaller companies, because that's like fed through, they all specify a PAS 128 survey when they want a utility survey. Now, there's still a bit of a gap there in terms of what they understand a PAS 128 survey to be. And there are still, I think, companies who are providing utility surveys, calling it a PAS 128 survey on the basis of them doing a few things that are similar to, or doing a few things that are required by the specification, without fully meeting the whole demands of the PAS 128 specification. And I think that's now where the gap in client education and maturity lies, being able to really get across the difference between a well-executed PAS 128 survey and a survey that just has confidence levels on the drawing or has PAS 128 on the drawing title. Like there is a difference, and that is now our next stage in trying to teach people really what it is. Humor and the accreditation scheme is part of that. It takes a little bit of the work out of it for the client, because they know that somebody else has done it. In this case, Lloyd's Register, who are a really well-respected company in the assessment sphere. They do lots of stuff for gas, for water, for a range of other types of surveys, including BIM. Actually, I think they've got a BIM accreditation that they maintain. So it's a well-respected body, and it takes a little bit of the work away from clients, but it's still something that we need to work on.
Yeah, and I was just thinking in the background where we're talking about the client awareness and PAS 128 being, it needs to be asked for ultimately. Again, maybe for an audience new to the concepts of information management, particularly BIM and the broader, do you see more clients asking for BIM? And again, not for you, because I know we've talked about it. We used to be on survey for BIM for people listening or watching, I'm referring to what was called BIM level 2, PAS and BS 1192 series, and now the ISO 19650 series. Do you see more clients starting to ask for that? Because that provides the framework, doesn't it? Or it's a help, let's put it that way, at least.
It does. And to be honest, within the utility sphere, I don't think I do. We get some people asking for it in 3D. So I have a feeling that possibly the BIM aspects of utilities are being done slightly removed from the survey profession. PAS 128 is a great way to actually sort of standardize the data, which then will help other companies who are putting it into their BIM models all have a one sort of vocabulary to work with in terms of the information that they're getting and how they fit it into their models. But we don't get a lot of requests currently for information to be provided to a BIM sort of schedule of works or program with different layering conventions and all that kind of stuff. So it's still not quite there yet.
So there's an opportunity for people listening or watching or whomever around that, what used to be called employees information requirements, now the exchange information requirements. The document, if it's in there, you have to do it, because that's where I would naturally see PAS, or where PAS 128 would be referred to. Again, this is for other people, I know,
Yes, yeah. I think that might be partly behind the sort of the growth in requests for PAS 128 surveys, but it is built into those documents earlier down the line. I think there is still a slight disconnect there in that PAS 128 specifies how a survey is done and the types of information that should be presented in the survey. It doesn't always go down to a further level of detail into exactly sort of how that data should be presented in a very specific format, as might be required for sort of data sharing across a wider project or wider scheme, right down to sort of the level of detail that is often specified for BIM projects. And so that can then still be up to the individual company as to how their layering is set up, how their naming conventions are, what colors they use for different utilities, how much information they exactly give over and above the basic stuff as asked by PAS 128. And that's probably scope for growth. So we can get more details so that we can have this sort of standardized format that can then be plugged into any model or any project, which would be great. That's another thing that we've been looking at with CICES, Institute of Civil Engineering Surveyors, the idea of the naming conventions and layering conventions that can go for utilities. And then hopefully onto topo surveys, topographical surveys, onto all sorts of surveys, and just push that forward.
So that's something. So thank you for mentioning that. I was actually going to come on to what's existing professionally or as an industry, should I say, as well. So is there a guide, for example? And I'm on the periphery of survey, so I don't know everything about survey. But are there guides that say now these layers and leveling, or you said that's something that's been worked on, or would there be a de facto standard? If I, as a client, if I asked you for a utility survey, you'd give me your standard. Is that based on an industry norm, or how does it work?
No, not really. I think it's developed over time. It's a lot of it has been pioneered by the Survey Association. They first came out with a guide to utility surveys where they promoted a scheme which was different levels of survey. I think it went from level 1 to level 6. That then got taken up and developed further by PAS 128 and the specification. So that now specifies sort of how survey information might be presented and methods of how the survey should be carried out. And that's about as standardized as it's got currently. The actual presentation of that data is left largely up to the producers of that data, those surveys to do. It could be standardized further. I would be in favor of it being standardized further, but lots of companies like the individuality of their output, and they know that, and we do as well, I suppose, to a certain extent. Like our survey looks different to a survey carried out by another company, and it's nice to have that. But I think there is scope for further standardization just to help everything tie together a little bit more. It's the same for topographical surveys, same for other types of surveys, but aren't really any one set of standards that I could point to if you were to ask for it. There are varied ones. The highways has a standard, but yeah. But
this is more presentation, and again, for people listening and watching, that the presentation isn't necessarily linked to the data captured, right? I mean, I know we've intentionally, I'm probably conflating all of it, which probably doesn't help the conversation. But yeah, the presentation, when it's digitalized, again, for the benefit of others, the presentation is second. I mean, it's important to the client, but it's easy to change the presentation. I think, have you got, I know this might be very obvious to us, but can you just explain that decoupling of when things are digitalized? The output isn't necessarily a PDF, and the output could be digital. It's decoupled. The data is the data. The presentation is the presentation. Have you got anything to say around outputs in PDF versus native format? Are you seeing clients asking for more native sort of formats rather than just PDFs and paper?
So we always provide our CAD drawings as well as PDFs. And PDFs they were just a sort of almost a digital paper representation of a CAD drawing without the functionality of the CAD drawing. Now that's changed a little bit as they've developed, and now you can get layering, and you can turn things on and off in a PDF in the same way as you can in lots of different types of CAD softwares. But you still don't get the full essence of being able to sort of scope down and identify a point and get the coordinates and information from a point, which is the important part quite often of a survey. And that's where, as you say, that's the decoupling of data to presentation. You want to be able to truly know if you've got a line on a map. Now that line hasn't been surveyed at every sort of centimeter segment. If it's at one level of survey, it might have been measured every 5 meters. If it's another level of survey, it might be measured every 1 meter. And now you've got obviously more confidence if you've taken a measurement of the depth along every meter, that depth is likely to not change in between those measurement points, as you might have with something measured over 5 meters, or even if it's not a PAS 128 survey, 10 meters or more. And being able to identify that is a real value of having it in a proper digital format. Now that gives, say there's lots of raw data formats. As you've got CAD. I think in a way, I use CAD every day, but I'm a big proponent of GIS, mainly because you can have all of the extra metadata and attributes sort of associated with it. So if you click on a node, you don't just get an XYZ coordinate and maybe a text label, but you might get a little table which details everything about that node, the pipe material, the pipe diameter, when it was laid, anything really that can be put in, and that's the power of something like GIS and other types of formats which are able to be much more attributed for each data point.
Yeah, it's a good point. Of course, I'll have to remain commentless about whether CAD or GIS is better based on my background. But I think one thing to say is things are coming together as well, but it's definitely based on everything we've been talking about: metadata, attributional parameters, and it's coming together. I mean, one example, I wouldn't normally mention companies, but it's a fact that sort of Esri and Autodesk obviously have a strategic relationship now, and that's quite clear. So again, things are coming together, things are being joined up with the standards that we've been talking about. Just quickly shifting gigs, I realize I haven't got too long left with you. So completely changing tone, if you don't mind. I wondered if I might ask you just about survey for BIM. Now, we've been on that together, or we've been involved with it, but can you tell us about it? Is it still active? What's been done in the past?
So I haven't had a lot of association with survey for BIM over the past few years. My main attention has been towards developing the PAS 128 accreditation scheme through TSA and trying to launch that, and working with CICS. As far as I'm aware, survey for BIM at present is what's the word? Maybe hibernating. I'm not sure. I don't think it's particularly active. They last published a digital plan of works, and that was received, I think, with fairly well within the industry and wider profession. But I don't think there's any plans for any updates on that at present.
That's fine. What I'll do, I'll follow up with others that are linked to it. But I was just thinking of where people could find more information. So I mean, maybe on that point, that was my sort of thought process. Where would you recommend people go to get more information about either the accreditation or just generally what's emergent? Things move on. Where do you recommend people go to get more information?
So the Survey Association website is a great place to go. From there, you can find out information about the PAS 128 accreditation scheme, but also I would recommend anybody with an interest in any aspect of survey to check out the Survey Association's publications. They've got a range of client guides and papers and documents on a whole host of survey topics. They're free to access. You can go onto a website. You just have to type in your email address to get them downloaded and sent to you. But I think you can tick a box to say, don't contact me again after putting that email box in. But I know they're used and read globally and well respected across the world. And the TSA puts a lot of effort into sourcing the leaders in the field of whatever subjects it is, whether it be building surveying, laser scanning, hydrographic surveying, to write these guides and updates on what's going on and what the current state of the art is in any one topic. So I'm actually meeting a group from Malaysia in a couple of weeks who use the TSA's guide to utility mapping, essential guide to utility mapping, which I helped author, and they use PAS 128, and they've been using that for a long time and developing their standards based upon that information. It's quite sort of heartening, really, to know that our work here in the UK is looked upon by so many people from across the globe as being, sort of the state of the art and the standards to aspire to. So, yeah, very, very heartening.
I think that's a really great example because, certainly standards and structuring the way we do things in the UK, we are respected, and there's, like you say, and also with the internet now, obviously it's an obvious thing, but these things can go global. It wouldn't have been that long ago where that would have been unheard of. If required, things can be translated as well. And I think that's interesting thing about data and information management concepts. They don't... it doesn't matter what language you're thinking; it's the same challenges. Just to summarize, I've literally just got a few minutes left, so I'll share the links of the websites. Thank you that you've mentioned. Okay. Obviously, I'll put a link to the PUMA accreditation for PAS 128 as well, and the TSA website. we've mentioned CICS, and I'll link to that as well. But just out of interest, is there an emergent piece of either technology? I don't get too techie on these things, but nevertheless, because you're a geophysicist, what emergent technology? I might not understand what's out there. So we've got drones in more sort of more non-geophys. Is the technology emergent that's sort of changing the game in geophys, or anything that's coming? Or
so there's two things. There's two things I can talk about this. First, I would say that really it's fusion of existing technology that is making the difference in geophysics at the moment, specifically for utility mapping. Some of the new multi-channel ground penetrating radar arrays, which are larger, they basically get 30 or 40 individual antennas all in one box, and you can survey large areas really, really quickly. You can combine those with LiDAR scanners to do mobile mapping, and then you get your point cloud of the above ground, and you get your sort of GPR data linking into the underground. That's sort of really exciting developments at the moment, because it also means data can be collected much quicker. You don't have to pay as much for traffic management, and it basically reduces the cost, reduces the time, gives you a higher sort of a better standard of GPR data quite often, because there's more channels and more antennas being used. So that's an exciting development. You still need to have some of the more traditional techniques to supplement it. Electromagnetic location, your traditional Cat and Jenny type things are really, really effective, and GPR will never replace those as being the standard go-to techniques for utility mapping. It'll always be a sort of an extra add-on and complement. But that's all good there. The second thing I would probably say now is that with the increase of availability of geophysics and tools like ground penetrating radar systems, there's also been a rise in people trying to take advantage of that and market tools that have wild claims and claim that they're working on geophysical methods and techniques and principles, but really they're just scams and they cannot work. So things which, for example, might proclaim to be able to find all types of materials, things which are really easy to use with a very limited understanding. If it's just a push button technique and then it doesn't give you any sort of data or background on exactly how that method is used, what physical principles it's based upon to work. And people who claim that maybe you have to believe in something for it to work, or you have to have confidence in the technique, they're generally, if something's too good to be true, it usually is. And there's people making a lot of money and selling equipment for thousands and thousands of pounds, and it's basically just a bundle of electronics in a box. I think that doesn't do very much. Somebody was imprisoned in the UK not that long ago for selling so-called bomb detectors to Iraqi military outposts following the Iraq War, and it found out that it was just a bit of electronics in a box. It made a beep sometimes, and people were actually risking or putting people's lives at risk because they thought that they were really detecting bombs and IEDs within vehicles, or that they were declaring that a vehicle was clear of IEDs and bombs. And actually all it was a scam that made somebody a lot of money, but ultimately they ended up in prison. And similarly with utility mapping tools that claim to be able to find everything, it's asking people to put a little bit of faith in something, and then they may go dig a hole, hit a 11 kV electric cable, and that might be that. So it is really risky and it's really dangerous. And unfortunately, it's something that keeps coming up in the geophysics industry, people trying to sell instruments that claim to be able to do things which are basically beyond the realm of physics. But people don't understand physics quite often, and salespeople can be very convincing. So it's just a case of hopefully being able to rely on the professionals within our industry to stand up and say, look, this is not right.
Thanks, Sam. That's probably a good place to sort of end, because I'm when you started talking on that point, I sort of was smirking to myself, thinking about dowsing maybe, but then of course it becomes, quite rightly, as it would be, it's very serious, right? I mean, this is very serious and almost unbelievable that people buy into these things, but if you don't know, you don't know, like like you say, the physics behind it, and why would people? So I think, sorry,
that's the thing. But most people don't understand how a ground penetrating radar works. Most people don't understand how a Cat and Jenny works even, and quite often a lot of people will place their faith in a Cat and Jenny because they've been shown how to use it. They might not understand how it works exactly, but they've been shown how to use it. And if you look on the internet, you can find out exactly how it works. Whereas some of these new things, they're basically depending on people's faith in the tools that we currently use that have been proven to sell these new tools, and they say, oh, it's basically the same as this, or basically the same as that. And people want to believe that they can find something, and it's it is really dangerous. Like dowsing is one of those things that is a little bit funny at times, but it's also something that undermines other types of techniques and other types of methods, and it's a difficult one. But
it's a good point, because in my career I've used lots of different sources of data. This primary data collection, if you'd call it that, I mean, I don't know, or data capture, is even I often forget what data is used for, you know what I mean, sometimes. So it might be satellite imagery to do with environmental, and I'm not saying that's less important, but it's a different time frame and there's a different immediacy. If you get engineering quality information wrong, or it's not using the right equipment that you've just identified, that can be, and often is, deadly. And I think we want to leave on a high. So but the high is there is a standard. So mention PAS 128, PAS 256. If people want to look that up as well, I'll link to both. There's the accreditation, which I know we've mentioned several times now, but the fact that there's a need for this rigor, this structure, this professionalism is, I think it's a very positive thing. And sorry, just one thing to finish on. I think because people are reusing the information that we gather, or people like yourselves gather and reuse, it's becoming more important, because I know through conversations generally with people in survey, you might think, oh no, things are being automated, and based on what you've just been saying, I think actually no, it's becoming more important than ever to be a professional survey professional and have that rigor. So I'll thank you there. Thanks so much, Sam, for your time, your insights, telling me about GPR. We didn't mention Cat and Jenny, but don't worry, I'll put a link in there. People think, what's that?
What's that?
I let that go, don't worry. I'll put a link in there, and then maybe people think, oh yeah, I'll look that one up, if they don't know. But yeah, thanks so much for your time, Sam Roberts, and I appreciate you sharing everything you have today. So thank you.
No, thank you. It's been a pleasure.
Just a reminder that you can access all the podcasts in video and audio if you visit bimtube. So our website again is at bim.tube.